Welcome students to another video lecture with Mr. Kinnett. In this 11.4 to 11.8 lesson, we're learning about transformations, and there's 4 transformations we're going to be focused on throughout this lesson. So go ahead and pause here, copy down what you see, and I'll see you soon. Welcome back. So our essential question here is going to be, how do we perform transformations on the coordinate plane? And again, we're going to be focusing on 4 separate transformations. So the 4 transformations we're working on, we're going to have a translation that's going to shift the same figure up or down. And it's really important that you realize this word has shown up. What does congruent mean? What does congruent mean? Yeah, if you said the same, you are correct. So we want to pay attention to this congruent because certain translations create exact figures and they just shift around, turn around, or reflect off something. While this last one, this dilation here, is going to make your figure get bigger or smaller so that it won't be congruent, it will be what's called similar. And what similar figures look like is they look kind of the same, they're just different sizes. So again, each of these, reflection and rotation, are all going to stick with our congruent image and our congruent mirror image. And you may have been catching up on some vocabulary here. We're going to use figure as the original, image as the thing we're creating. And throughout this lesson, whenever we create an image, the new thing, it's important that you represent it somehow on your paper to know that it's something new. So I'm going to usually show that with a different color, or you can use dotted lines. So dotted lines is also a good system. So let's start moving on here. I'm going to jump 2 slides ahead, where we're going to start working on our first transformation, the translation. So pause here, copy down what you see, and go ahead and get ready to do this problem. Please realize I'm leaving the space on the right side of these steps right here so that we can actually use a table. We're going to use a table, a T-chart like we've used before for like mean absolute deviation. So again, pause here, copy down what you see. Oh, graph, exactly. It has to be graphed on graph paper, exactly. All right, welcome back. All right, so we're going to learn how to translate figures. And really the key to any translation, rotation, reflection is you're going to have to figure out the corners of the object. So we're going to try and find the x coordinates and the y coordinates for like the vertices. Remember from our previous polygon lessons, those are the corners of a 2-dimensional figure. So we're looking for the vertices. And on this figure, we have 4 vertices. We have the upper left, the upper right, and lower left. So on our notes here, we're going to create a T-chart, and it's going to be a little tight for me. Leave space so you can read yours. And in our T-chart, these are going to relate into functions in our next chapter. So again, practice making this T-chart when it's pretty simple, because it's just going to get a little more challenging later. So what we're going to do is we're going to put the ordered pair, the original ordered pair, in this first column. And what you're going to get out of this right column is the new ordered pair. And I'm going to abbreviate OP because I'm out of space, but you may want to write ordered pair. And what I mean by new ordered pair is that's the images ordered pair. So this would be the images information. And the starting point is the figures information. So go ahead and write down the 4 ordered pairs we just marked down. So we have our first ordered pair was 2, -1. Then we have 1, 2, 3, 4, -2. And then we have 1, -6. And lastly, we have 1, 2, 3, 4, -6. Okay, hopefully you were able to read those ordered pairs because that's going to recycle throughout this lesson. And what we're doing here is, according to our directions, we have to translate this figure 6 units to the left. What is left on the coordinate plane? Is that the x-axis or y-axis? Yep, it's the x-axis. And when we go left, is that a positive or a negative number? Yeah, it's negative. So what we're going to be doing to every ordered pair is taking the x and minusing 6. And then for the y, we have to go 5 units up. Well, is up positive or negative? Yeah, it's positive, so we're going to write plus 5. And this is how we're translating. So this is the translation here in the center column. And we just have to do this translation for every single ordered pair. So I'm going to model the first one here. We go in there, we put the 2 in the first part of the ordered pair. And remember, this is an ordered pair. So we're showing it 2 different, we're going to do the math on the x coordinate and then the math just for the y coordinate. This comma splits the 2. We have -1 plus 5, and we're going to get our new ordered pair. So 2 minus 6. Well, that gets us -4, and I'm kind of writing it crooked for space, comma 4. Because -1 plus 5 is 4. So that's how we're actually creating these new ordered pairs on our image. I'm going to let you do the math for each one of these, and we're going to finish this in class. So let's keep on moving ahead here. You can finish this problem now, and we'll check it in class. But we're going to jump to the next transformation. We're going to talk about the reflection. So again, pause here, and please begin to copy down what you see. Okay, welcome back. So what we're about to do here is we're going to use the same T-chart process for finding a reflection. And it's going to be important that you realize there's different directions for x-axis reflection than there is for y-axis reflection. So we're going to model the x-axis reflection here, and then we can do the y-axis reflection together in class. But I'm going to do it with a T-chart, just like I was showing before. Okay, and the first one is our ordered pairs. This center area is going to be the reflection. And then we have our new images ordered pair. Again, I'm going to abbreviate that OP. So just like the previous problem, we have to write down the vertices ordered pairs. So our vertices ordered pair in this problem is -1, 2. We have -4, 3. And we have -4, 5. Those are the vertices ordered pairs of our triangle here. Now, since we're doing an x-axis reflection, we should have a mirror image of this blue image that's going to reflect down here. And it should look like the mirror is the x-axis here. Okay, so how we do that's quite simple. All your x coordinates are going to stay the same. And what we're going to do for the y coordinates is take their opposites. So how that would look as a function is you would write x, comma, -1 times y. We're going to take the opposite of all the y's. And how you would still substitute in this. I know we can do this in our head, but again, I like to model how it should happen, so when it gets a little harder, you still know what to do. And the new ordered pair would be -1, -2. And we would do that for each ordered pair. We have -4, -3, and we have -4, -5. All we have to do now is plot those ordered pairs. -4, 3, and -4, -5. And when you connect those dots, again, I'm going to show it with a dotted line. Well, let's make sure we get it dotted here. You're going to notice it should look exactly like the other image, just reflected over the x-axis. Okay, so that was our reflections. Let's keep on going. Our next, and again, we'll do the y-axis reflection in class together. We're going to move on to the next one. And our next one is how to rotate a figure. And you're going to need to make sure that your note is outside of your paper right now. Wherever you're graphing this figure, you're going to make sure it's outside of your paper, because really one of the easiest ways to do this is to just turn our paper and then write down the ordered pairs that we see there. So pause here, copy down the directions for a rotation. Okay, welcome back. So, how we're going to do this is we're going to do a rotation of this figure 90 degrees clockwise around the red colored ordered pair. Now, when I start doing this 90-degree turn, you're going to feel like I'm just turning the figure here, but I want you to realize that you should be turning your paper. And when you rotate your paper, this will be the y-axis currently, right? So once you rotate the figure, I want you to realize that you're turning your paper when I do this. And all we're going to do is rotate it 90 degrees clockwise, and whichever axis is now back looking like it is the y-axis, we're going to call the y-axis. So one more time, the way this problem actually began was, oh man, here we go. This is how the problem starts. So we have our y-axis, we have this beautiful coordinate plane there. And what we're going to do is really, we're just going to list the new ordered pairs for this one. Okay, so we have to rotate the paper 90 degrees clockwise. So take your paper and turn it 190-degree turn clockwise. Awesome. And now what we're going to do is write down the ordered pairs of the vertices that we have once we turned it. So our new ordered pairs are 2, 1. We have 5, 1, and we have 2, 5. Okay. Turn your paper back to its normal position, because remember, they like to see the rotation in these problems. We can't just claim it doesn't happen. Together. Okay, so we got it all over there. And now we're just going to plot these new images ordered pair here. We have 2, 1. We have 5, 1. And we have 2, 5. And 2, 1. And I missed 5, 1. And notice when we connect these wonderful dots here, it should look like it is rotated 90 degrees, just like when we turned our paper. And that's the rotated image. Not too difficult, is it? Now we have one last lesson here. We actually have a couple things we got to go over. This is called rotational symmetry. So rotational symmetry is when you're able to rotate a figure and it still looks exactly the same. So this star may be the easiest one to see. So when I rotate this figure, just like that, I have created the same exact figure. So what we're going to try and figure out here in class together is how many lines of symmetry do these shapes have? So copy down the shapes, and we'll actually talk about this part in class. Okay, welcome back. We got one more piece to go. I know this is getting pretty long here. We're going to move on to the last part, which is a dilation. And what property of math are we recycling for this? So as we do this, you're trying to think to yourself, what property of math are we actually doing here? We're applying something we've done before in the past, and it's a property that we've used. So keep that in mind. So just like all the other problems, again, the t-chart starts coming. I think rotations was our only one we didn't t-chart. And again, you're going to put your ordered pairs here. I'm going to just abbreviate it. And our last column, we get our new ordered pairs, or the images ordered pair. And in the middle here, we're going to do the dilation. So we have to get the vertices ordered pairs. We have 0, 2. We have 2, 2. And we have -2, -2. Now those are the vertices. Now on a dilation, your figure should get bigger or smaller. It's not congruent. This is the one transformation that's not congruent. Okay, so what this problem is asking us to do is a factor of 3/2. Well, we see the word of. What operation is that? Yeah, that's multiplication. So what we're going to have to do is 3/2 times our ordered pair. Now think, what is this property we're going to use when we have this multiplication here on a parenthesis? Yeah, if you said distributive property, you're right. So what we're going to have to do for each of these is to distribute the 3/2 into the ordered pair to get our new ordered pair. And that would be 0, 3 for this first one, because we're just doing fraction multiplication. 2 times 3/2 is 3. When we do the 3/2 here, we're going to end up with 3, 3. And when we do the 3/2 on this ordered pair, well, we got negative, so we actually end up with -3, -3. And we're just going to graph those 3 lines here. And as you would expect, our dilation, when we used a number larger than 1, the figure should get bigger. If we use a number less than 1 but greater than 0, the number will get smaller. So when we connect our dots for this new figure here, we end up with a larger shape. If you have any questions at all, please make sure to write them down. I think I have one more slide to have you write some information down. But that's it. I apologize for the super long lesson. I'm probably going to have to split this one up for sure. But please watch the lesson again if you're confused on any of these, and we'll go over a couple of the problems in class. I'll talk to you soon, students.